safety, and then we just present it. That's all it
Yeah.
is.
Yeah, you just present it. I mean, here's the thing too, and this is kind of running in the background with you guys. A couple of years ago, the college started an incentive for it's called EPIC, effective personal and effective professional interpersonal communications. And really, it's not a grade that goes in the books as far as ELW is concerned, but I write down some information there, and then I relay it back to the college. Well, you know, and I'm just going to pick on Trapezi because he's a year late.
Oh.
Trapezi comes into class. He stands up in a group in front of 10 other guys and 2 professors, and he feels kind of, you know, he doesn't project well. He kind of messes up on his words, and he's kind of shy and everything like that. Well, you know, we'll coach him through the process of being able to stand up in front of a group, feel confident what he's talking about, and give a good presentation. Now, this works both ways. One is when you guys go into an interview, we want you guys to, I don't want to say be overbearing, but be assertive. You know, we want you to sit down when they ask you a question, you know, come forth with a good answer and look them straight in the eye, and all these good things that are going on in an interview, and not kind of be kind of laid back. And the other thing is, and this is definitely gained some hype in the last, I'd say about 10 years, is companies kind of slacked off their marketing as far as signage and online and all this stuff. And guess what they're using for a marketing tool? Take a guess, Noah.
No, you.
There you go. All right. There's no better marketing tool than Noah Oliver standing out there in a Duke Energy uniform, looking all high and tight and muscly. You know, he's got girls hanging off his arm. Right? And he's out there in the world, and he's mobile. He's around. People see him all the time out there in public. For a customer to be coming up to you and asking, well, what's up with Duke Energy and the new rate hike? Well, you're not going to turn around and say, I don't know, walk to your truck and go eat some crackers. You're going to have to be able to speak with those customers and at least give them the right direction of where they need to go. Sorry, sir. Sorry, ma'am. I can't answer your question, but we do have some information. You get the idea. Yeah. So it definitely helps you out in those areas. So, yeah, I mean, prepare. I think that's probably one of the worst things that we've seen in class is, well, I don't have the alphabetical list here. Let's see, Ingersoll, Hawk. I think Hawk's at the top of the list, isn't he?
Trapezi.
Yeah, Trapezi. Yeah, Trapezi's at the top of the list. He walks into class or gets online here at 8, 9 o'clock in the morning and says, is it my turn? Well, hold on. And starts doing something on his phone. Be prepared than that before.
Yeah.
Okay. Any other questions on that?
Nope.
Good to go. Appreciate it, Professor V. All right. Somebody has to say something?
I did. Do you want to watch that video now, or
yeah, sure. If you want to share it, go right ahead.
Yeah, I'm gonna share it. And Jerry, you came a little late. We're talking about doing safety meetings in the morning, and you're going to be the next guy to you'll do a safety video first. But I'm gonna take care of this morning, so I'm gonna share my screen. Everybody see that?
I do not. Now I do.
Sure.
Let's get over here.
Yes, sir. Well, if you didn't mute me, I could tell you I see it.
Well, what's happening here is you guys that are, and I'm sorry about that, but I picked on everybody there. You guys that are adjusting your cameras, and I get to see the palm of your hand and sneezing and stomach's roaring because you had too much to drink last night. But...
Okay, we ready to roll with it? All right, guys. One of the biggest things you're going to learn about when you go to a utility is your PPE, and it's that, you know, of course, that means personal protective equipment, and that first word in there is personal. So just the video I'm going to show you right now is about rubber gloves. I've always, you know, my 32 years, I kept 2 pair of rubber gloves on my truck, and I really frowned on somebody else coming up and grabbing my rubber gloves, because that's my personal protective equipment. That protects me from, you know, de-energized things or stuff that had potential to be energized, and everybody has their own PPE like that. So I encourage you to use your own. Not only that, is like what we're going through right now with the pandemic. It's a health issue as well. It could be if somebody's got a cut on their hand. You don't want them with their hands all up in your rubber gloves. You just want to make sure you've got your own PPE and you keep it clean. So I'm gonna play this little video. It's about 3.5 minutes long, and this is just an example of what we're looking for in the mornings. Let me know if you can.
Here we have a standard high voltage glove with no obvious signs of damage. We placed it on this mold to simulate a worker's hand. So let's see what happens when we bring an energized source near the hand. Obviously, electricity has a way of finding defects easily missed by the naked eye. That's why OSHA requires us to perform a thorough inspection of your rubber gloves before each use. Let's take a look at the inspection I did before this demonstration and see how this problem could have been avoided. OSHA requires rubber gloves to be electrically tested every 6 months, so before going any further, be sure to check the test date. To inspect my gloves according to ASTM standards, I'll first gently roll the entire outside surface between my hands. Always inspect both the outside and inside surface of each glove. If you find any suspicious areas, perform a more careful inspection by gently pinching and rolling the rubber between your fingers. Pay special attention to the base and tips of the fingers and thumb. Carefully pull them apart, looking for any irregularities. Let's move on to the next part of the inspection, the inflation test. There's 2 ways to inflate gloves, either manually or using the portable inflator. To do it manually, roll the glove up about 1.5 inches. This will trap air in the palm and fingers of the glove. Then squeeze it and hold it up to your ear, listening and feeling for any air leaks. I can feel an air leak in the palm of this glove. At this point, you should destroy and throw away the glove. But before we do that, let's do the other test using the portable inflator. First, slide the glove over the inflator. Once you get the base of the glove over the inflator, roll the rubber O-ring onto the glove. This will prevent the glove from flying off when you inflate it. Now inflate the glove. Make sure that you don't overinflate it. This particular glove is a type 1 glove, which is non-resistant to ozone. It should never be inflated more than twice its normal size. If you have a type 2 glove, which is ozone resistant, it should never be inflated more than 1.25 times its size. Once again, hold the glove up to your ear and listen and feel for any air leaks. And sure enough, I can feel the air leaking out of the palm of this glove. I prefer to use the portable inflator because it gives me the ability to air test the entire glove, not just the palm and fingers. Keep in mind, if you work for a company that has state OSHA regulations, you may have more requirements for rubber glove inspection. It just took a single pinhole to ruin this glove, so it's extremely important that you always inspect your gloves before each use and immediately following any incident that could have caused damage. It's the only way to be sure that you're protected.
Guys, there's also another way you can check your rubber gloves. This is the way we were taught to do it when I first started in the line work. At our location, you can also fill that rubber glove up with water, and just like you rolled it from the cuff down toward the hand to see if there's an air leak, you can do that. And a lot of times, you know, you get a little stream of water coming out, a little trickle of water, but you have to be very careful with your rubber gloves. You want to protect them. You want to keep them in a glove bag. That's your lifeline when you're working on any kind of energized equipment. So you guys got any questions about any of that, about the video, any comments? Okay, I do have a pair of rubber gloves in the back of my truck. I think some of you guys already looked at it. We will get into glove protection in the blue book, I believe it is. And we'll talk more about it, but a lot of stuff he talked about in that video, you probably will see on a test at some point, talking about how to check them and when you check them. Can anybody tell me how often or when you would check your rubber gloves?
Every 6 months, or after you might have done something to mess them up.
All right, every 6 months, you're going to send them in to be tested. But you want to test your rubber gloves before each use or every day. You know, sometime just before you get ready to start your job, you want to check them rubber gloves to make sure you hadn't, you know, picked up a pinhole or some kind of damage to that glove during the day. So you can look for those kind of questions. Like I said, that's going to be in the blue book coming up, and we'll go into more detail about rubber gloves and rubber glove safety and things, what we're going to do with that. So, and I do, up in my office, I do have a rubber glove tester just like the one you saw in the video, and you guys will be able to, you know, test them yourself, those kinds of things. And like I said, that's probably one of the most important parts of your PPE that's out there for a lineman. Any questions, comments?
Yeah, I got a couple comments there. You covered that very well, but I really like your statement that you said there in the beginning about your rubber gloves. And guys, take this in consideration for all your tools, your hand tools, your climbing tools, your rubber gloves, everything that's assigned to you. We typically had one bin on a truck that everybody locked their tools up in. Right. Do that, and don't. It's going to come to a point one day where somebody's not going to have something. Try not to share your stuff. It happens on the yard with us. Well, yeah, I'll lend you my lineman wrench, and guess what? You don't have a lineman wrench anymore. As far as those rubber gloves are concerned, man, those are your babies. Do take care of them. Hold on one second. If you could stop share there, Robbie, let me get over to another, and I'll share mine. Yeah, this is a good one. And you guys saw how short and simple that was. Okay. All right. I'm sure you guys had some concepts out there, and you've seen some bucket trucks operate out there in the world. Let's share screen. 2, share. Okay, can you guys see a bucket truck?
Yeah.
Mm-hmm.
Okay. All right, well, and there's many varieties and types and everything like that. This is your typical distribution bucket truck. I would say, by looking at it, that's probably about a 50, 55-foot boom.
Right.
And I'm gonna get the drawing over here so you can see a little bit better. All right, it's hard to see in this picture, but I'll mark them out in red here. There are points on this bucket truck that are insulated, and then there's some points that are not. So, and they'll actually be on the bucket truck with arrows. So if you see that red line right there,
yep.
And that red line right there, that's the insulated portion of the boom in the upper boom. That's the upper boom part. Now, how much insulation does it have, gentlemen?
100,000 per foot.
100 kV per foot. Yeah. Remember that through the entire industry. If you've got a stick that's fiberglass in the industry, it's 100 kV per foot. If you've got a boom that's in the industry, it's 100 kV per foot. Now, to maintain insulation between the bucket and down here where all your controls and motors or anything like that, they have fiberglass sticks inside, which of course are 100 kV per foot. So that's the insulation portion of the upper boom. They've also got an insulated portion down here in the lower boom in case you make contact anywhere in this area. If you make an electrical contact with the boom up in the air here, this is what insulates it from going down through the truck to the earth. Now the bucket itself, has insulation in it. So you got
Do you have
100
to-
kV and up. Excuse me.
Do you have to ground the truck when you're?
You do, and I'll get to that.
Okay.
Thank you. Now you have 100 kV. Does everybody understand what I say per linear foot?
Is that square footage?
No, linear.
Linear.
Okay. So
Yeah, the electricity's going to travel on a line, not across the whole thing, right?
right. So if I came down here in a straight line, it's not really straight. That's a linear per linear foot. So if I have 100 kV insulation per linear foot, that's in a straight line. Now, if I went like this, and you see some insulators made like this, I've got to include this distance, this distance. It's not from here to here. We'll say that's 1 foot. Actually, this is about 3 feet when you add all these lines together because it's linear. 1, 2, 3, 4, 5, 6. So when I say linear foot, that's what I mean when I'm talking about that. Okay. So even, I mean, you've got 100 kV per foot of insulation on the outer bucket. There's a liner, fiberglass liner in the inner bucket. That's 100 kV per foot. I'd say this is probably what, Robbie, 15 feet?
Yeah.
15 feet on the upper boom section. So we're looking at 15 times 100,000. That's 1,500,000 plus another 3 here.
Yeah.
So that's another, so you're looking at almost 2 million volts of insulation that you have between the bucket and the earth and the ground. Do not consider a tire to be insulated. Why?
Steel belts.
Steel belted radials. There you go. Perfect. So with all that, guess what? You get an Altec bucket truck, brand new out of the factory. Guess what's in the first page of the truck manual? Big stars around it, written in red, bold. This is not an insulated aerial device, not meant for personal protection. Why do you think that put that disclaimer in there?
Because you can still get electrocuted with it.
In the real world, you keep this clean, all these insulated areas, there's no hydraulic leaks. It stays relatively dry. Now it can get wet, but you've got this thing, the truck is tested every 6 months also. You keep this all fine and dandy, it's good to go. But the manufacturer doesn't know what kind of condition you're keeping your bucket truck or any kind of insulated boom truck in. So they're not going to put in there that you're covered 100% of the time. What is the final barrier or the barrier between you and high voltage? What video did you just watch?
Rubber gloves.
Rubber gloves. That's it, guys. Your rubber gloves are the most important barrier between you and a path to ground. So that's why they put so much emphasis, and we'll go through later in the course of the ground-to-ground rule, all the rules that you have to wear in rubber gloves. Even Altec, and they're probably #1 in the industry right now for making bucket trucks and line trucks, won't put in there, yeah, you can jump in the bucket, you can go up there and grab 7,200 volts and be fine. They are not going to say that. Rubber gloves must be worn at all times. They're the final barrier. Any questions there? Okay. I'll say, Robbie, did you have anything else?
Good. That was good.
Okay. All right. So I'll stay on the share here, and we're going to go through a couple things. One is, I think I had the question the other day. So far, we've been talking about on transformers, we've been talking about single phase. One phase of primary comes out to 2 secondary. So we've had 1 phase of primary. And the question was asked, well, are we going to start talking about 3 phase? Well, today's the day. So I've got in my picture up here on the pole. And just to be square on everything that we're talking about as far as terminology is concerned, this is a 3 phase primary pole. You can count them up top. 1, 2. Why don't I just use the pen, Robbie?
Yeah.
Yeah, that would make common sense, wouldn't it?
Yeah.
I knew I'd do it. I lost my dang marking thing. Told you I'd do that one day.
Yep.
All right, so get back over here. This is 1, this is 2, this is 3 phases. Now, don't think that 1 is going to correspond with anything out there in the world. I'm just putting this in here for you to see the 3 different phases. And right down here, we have neutral. All right, most of your electrical system, the neutral is grounded. Well, what do I mean by that? Any guys got any ideas?
Where that copper wire runs to ground.
Copper wire runs to ground, right. You can't see it very evident in this picture, but right here, there's a copper wire that goes to the pole and goes down into the earth. That would be the pole ground. So that what we consider this to be is a grounded neutral. All right. Think of, and it's good to make this explanation out there in the world when you're talking with other linemen or you're taking tests like this. The neutral itself, wire, is the transport to ground, and ground is ground. So I'm not going to call the neutral ground. I'm going to call the neutral neutral. The ground that goes down into the earth, I'm going to call the ground. Does that make sense?
Mm-hmm.
The neutral wire is just to be able, well, I need to interconnect my grounds. All this is for, all the neutral wire is for, is to interconnect this ground to the next pole, to the next pole, to the next pole. So that's the interconnector. That's the transport portion of it right there to be able to get to ground. All right. So let's get some terminology straight. You might want to write this down. If I have one phase of primary on the pole, it's going to be in the middle. It's called single phase. If I have 2 phases of primary, not the third, this gets kind of strange because there's different terminology out there in the world. Robbie, you can jump in here. It's either 2 phase, V phase, V as in Victor phase, or B phase. Robbie, what'd you call it when you had 2 phases on a structure?
We always called it V phase.
V as in Victor?
Correct.
All right, V phase.
Yeah.
All right, and obviously if you have 3 conductors on the pole, it's called 3 phase. The symbol for phase, if you're writing this down, if you don't want to write the word, is an O with a slash through it. That doesn't make phase. So if you put 3 and that symbol right there, that's 3 phase. Any questions so far? Let's see. All right. Show you another picture here. We're getting a little bit ahead of ourselves. To be able to explain this is better if you see this tool. All right. The picture that you see right here, when we start getting into the primary voltages, you're not going to be able to put a simple voltmeter on those primary conductors, take one lead from the primary and one lead and go down to the neutral or ground to be able to get a measurement. You're going to have to use what they call a phasing tool. That's what you see in this picture. It's got 2 purposes right here. One, it can tell you what phase that you're on with some other procedures going on with it. And 2, it can tell you the voltage. It can tell you the voltage between phase and neutral, and it can tell you voltage between phase and phase. That is called, and just because of the brand name, I like the brand name, these are Hastings phasing tool. Can you see in the picture right here? I seriously doubt it.
A multimeter on steroids.
Yeah, well, yeah. And I want to get to this right here to be able to show you. I'm sure you can't read that right here because I can barely read it from here. There's a number, it's got 40 kV. Now, does that mean it's got 40 kV of insulation?
I'd say it's probably rated for 40 kV.
There you go. It's rated for 40 kV. So I cannot test voltages above 40 kV with these sticks. Then there are different types of sticks that go up to, I think the highest they go up to, Robbie, is 69 kV.
Yeah. Sounds
Okay.
good.
So that's the rating of the sticks. Now you see on the connection down here, you don't just hold these by hand and put them on because you're going to have some distance to them. You can attach just a regular switch stick down here at the bottom, or you can attach an extension stick like we've been using out there in the field. And then you can move these sticks around and do these measurements. But I just want to let you know, and we'll get into this further, both on overhead and underground, how I'm getting measurements off my primary conductor. All right, so essentially, right here, I take the end, one of the hooks at the end of one of those sticks, I put it on a phase, and I put it at the other end of the stick on neutral. And we're going to say here, my line is 7,200. Not doing too bad for a mouse, am I? There's a little digital meter inside there that's going to tell you. There's a little digital window right here that's going to tell you, and I particularly don't care for the reading that comes out of it. It's going to give you a reading of back and forth, 7.2. That's those, it, how do you say the word? Not concatenates, but it shrinks the value down to a 7.2. That is actually 7,200. That's as far as the digits go on the stick is concerned. So if I put a stick here, put a stick here, you usually put your metered in on the primary side. It doesn't matter. You're going to get a reading of 7.2 on the sticks. Now, each phase, because it's coming from the substation this way, is 7,200. So every time you move the stick from here to here, this one stick, and here to here, you should get a reading of 7,200. Am I correct?
I would think so, yeah.
You were thinking correctly, yes. Remember, my transformer at the substation is not changing voltage. If its output is 7,200, 7,200, and 7,200 on all three phases that are coming from the substation, that's the way they're going to remain to be all along my circuit. So, stand by 1 second. Oops. Can you all hear the dogs howling?
Yep.
Can you really?
Yeah.
I must be forecasting rain. All right, give me a moment, gentlemen. Three phase. Well, that didn't work. Yeah, it did. All right, remember the other day when we talked about our three-phase generator right here? And how when the north-south, when we use A again as in this example, when the north hits the A on one side, it peaks, and when it hits the south on the same side, it valleys. And if you'll watch, this is the full positive side at the top where my mouse is at, and this is the full negative side. Remember, there's still voltage available, the peak voltage. We'll use 7200 because we're using 7200 in our example of the other picture right here. If you'll take a look, A is blue, B is red, and C is green in the generation process. Is any one, and the A, B, and C are phases, is there any one or two or three that peak at the same time another phase does? So I'll restate that question. Is A at peak while C is at peak?
Time, right?
Hmm?
It looks like it's one at a time, right?
All three phases are making electricity at the same time, right?
Yeah, but
It's
as far
not
as peak
peaking
goes,
though. I'm not right here on the green line. Right here in the, well, let's use the red line and blue because they're a little bit easier to see on your screens. At the red line, can you all see my mouse?
Yeah.
Moving up and down? I'm peaking full negative right here in red down here at the bottom, right about at this time. What's blue doing?
Going up.
Well, at the same time. See how this has got time written around it at the bottom? So when I have 7,200 volts right here on my B phase, do I have 7,200 volts at the same time on my A phase?
no.
No,
No.
I mean, it's way down. We might be getting maybe 2,000 out of it. I don't know. Same with the other C phase. It's well below peak. And A meets it right here. It's well below peak. While B phase is almost at peak. So there is a computation out there of how to measure the phase-to-phase voltage. And I can guarantee you one thing, guys. The engineers who did it, there's a slope time value. There's there's calculus that goes into it. But luckily, Lyman's got another out on this. Let me go over here to get back to this picture. Okay. So we'll redraw here. $7,200. $7,200. $7,200. Now this, when I put these voltages up here, this is your system voltage. Is there, by the generator picture, is there actually 7,200, 7,200, and 7,200 on all three phases? That would mean it'd be peaking, all three would be peaking. Is this happening all at the same time? Remember the generator picture?
No.
No, it can't be. By generation, by the way that you saw in the generator picture, that is physically impossible. It can't be happening at the same time. So there's an easy calculation number that you can use here to be able to determine what the voltage is between this phase and that phase, this phase and that phase. You're going to take the system voltage at peak, 7,200, and you're going to multiply it. Please put this down in your books. It pertains to all voltage, 1.7325. So somebody out there with that super calculator, multiply 7,200 by 1.7325.
It's 124.74.
12474. So it's 12 in a system that's going to be usually out there in the system. It's 12470. This applies to every voltage where you have three phase. So let me try another one. So if I was to take my stick now and not go to the neutral, take one stick here and one stick here and take a measurement with those sticks that I showed you, what should show on the digital display?
7.2.
No. 7.2 is phase to neutral or ground. What should I show from phase to phase?
Would it be 7200 plus 7200?
That's where we're trying to head here. All right. And we just back up a couple steps. So we looked at our waveform before. Can I get 7200 and 7200 at the same time?
No.
Can't
No.
happen. So what number do I calculate to be able to get my phase to phase voltage?
1.7325.
Excellent, excellent. My sticks should read what? We came up with 12,474. What should the sticks read?
That number?
No. Remember, 7,200 went to what? 7.2 is what came out of the sticks. What should come out on the sticks now?
12.4.
12.4.
12.5. The sticks are smart enough that 1, 2, 4, 7. All right, they're going to round that 7 up to 5. Okay. All right. Now you might see them fluctuate up and down because voltage does change along a circuit. You might see them go down to 12.4. You might see them at 12.5. But if you're right at the 12,470 number, it's going to take 1, 2, 4. Sorry about that. 7, 0, and it's going to round that 7 up. And on your sticks, you're going to get a reading of 12.5. All right, so let's go back real quick. Give you guys a little work on your own here. I've got to find my pen, Robbie.
Yeah.
All right. Phase voltage is 19,900. That's for all three phases. 1, 2, and 3. Question. I put one stick on the phase and one stick on neutral. What should my digital reading be?
19.9.
Correct. Everybody understand that? All right. It's not going to, it only rounds up the tenths and the hundreds to the tenths. It doesn't round. It's not going to say 20 kV. It's going to say 19.9. All right. I'm going to take my stick. I'm going to apply it to this phase and this phase. What reading should I get?
34.5.
All right, 34.5. Does everybody know how we did that?
Yeah.
I took my 19,900, used the same number, 1.7325. It gave me the phase-to-phase voltage. All right. I'm going to put a stick on this phase. I'm going to put a stick on this phase. What should the reading be?
The same number.
Same number.
Mm-hmm.
I put a stick on this phase. I put a stick on this phase. Reading?
Same number.
Same number. Great. You guys understand that it's a mixture of all phases. Was there a question there?
I got a question.
Sure.
I guess I'm thinking of this like like you would combine batteries, and I think that's messing me up. So the fluctuation is the 1.7325. Is that the deviation that the measurement's accounting for?
The measurement's accounting for it, and there's a lot of calculation that's going into it. That measurement, when you're using the 1.7325 number, is actually, take a look at, see my mouse going up? I can't draw on this picture because it's animated. See where my mouse is moving up and down here?
Yeah.
That finger? In time.
Okay.
At the instant that you take that reading, and remember this happens 60 times per second, I'm not getting 100% of C, I'm not getting 100% of A, but I am getting 100% of B. All right? Instead of you having to punch in a bunch of time, slope, variable, degree values, there's a simple number that you can use, and it's 1.7325 of the voltage from phase to ground. So don't think of it as a series circuit or a parallel circuit. Think of it more as, this is what my voltage is on a three-phase line in this instance of time. Does that make better sense?
Yeah.
Okay. And if you notice, if you continue down in this one cycle right here, let's use A for an example, the blue phase. There's actually a point in time where A is at what? Well, there's 3 times when it happens here, where A is at what?
0.
0. But because this one is just coming off the peak, not right at it, but it's just coming off the peak, and this one's just raising to the peak, that I'm still going to use the same value of 1.7325 times the voltage. Everybody, does that make sense to everybody? Okay. So, and this, like I said before, this applies anytime that you have three-phase. So, Robbie, do you have some typical three-phase? Let me get back to a picture here. Do you have some typical phase to ground and phase to phase voltages that you used on Duke? I just gave out the ones for Santee Cooper.
Yeah, we use well, they have some 7,200 left, but most of it's 13,200.
So it's 13,200 phase to ground?
Correct.
All right, hold on. 13,200. So that's per phase. So now you guys need to calculate and know out there in the world, what's the three-phase value? What's the phase-to-phase value?
Oh, where's my calculator?
What? Where's my calculator?
22.9.
22.9. Is that correct, Robbie?
That's right. We always called it 23 kV.
23 kV. That's fine. I'll fine and dandy. And I said something just before, but while we're with you, how many different voltages distribution did you work on in your system, Robbie?
Several.
Primary.
Primary, mainly 13,200 and 7,200.
Yeah, that's the way you're going to find most of your organizations. You'll find a couple small instances where different voltages have to be used because of the customer need. But Santee Cooper distribution throughout the state of South Carolina, now this is distribution, only uses 2 voltages. 7,200 phase to ground and 19,900 phase to ground. 12,470 phase to phase and 34.5 phase to phase. And that's all you're going to have to really be prepared for out there in the world. So let me give you one, actually, and you will see these later. Let me give you a secondary voltage. All right, secondary voltage of 120. What's the three-phase, phase-to-phase voltage?
Wait, so secondary is coming off the transformer? Or
Yeah,
what's
I'm just giving, don't worry about where it's coming from. I'm just giving the voltage. I want to know what the three-phase amount is. What do you multiply it by?
Is it 1.2?
No, sir. That same calculation for primary applies to all voltages once you go three-phase. 120 times 1.7325.
So it's 121.7325, right?
120 times 1.7325.
I was adding.
207.9.
Yeah.
207.9.
Right, and we call it 208. All right, I feel confident in, if you guys have any questions here, that you're now able to compute a phase to ground, which is pretty simple, stick on one, stick on the neutral, and a phase to phase voltage, correct?
Question.
Yes.
So you gave us the number for the three-phase. Is there a different number for two-phase?
Good question. No, but let's do this. Yeah. Yikes.
Right.
You should be able to use a eraser on a pencil. If the stylus don't work, it might work that way.
Yeah, whatever. Thank you for the recommendation here. I'm intently trying to get this done. All right, so I've got now a V phase, B phase, two-phase line. All right, got rid of the third phase in the center. This is how you're going to see it constructed also. I'll take my stick. We'll say the voltage here is phase to ground is 7,200. What is it between this phase and this phase measurement?
Uh, 1247.
Right, right. The removal of the third phase does not affect the voltage. Instead of taking the third phase and using it in the calculation, you're only using two. So we'll go the, because they look so good right here, the A and C phases, we'll say on the pole, and we'll talk about how we're able to designate. We'll say this is A. We'll say this one's C. You still use 1.7325 because the voltage is being measured from this point right here in time. All right, so V phase, B phase, you still use the same calculation. Good question. All right, any other questions here before we move on how to take a measurement of one phase to ground and phase to phase, plus the calculation that you need to be able to compute phase to phase? Hearing none. Robbie?
Stuff.
Back this up to the video we just talked about. Why do I need, if I know my phase voltage is 7,200, why do I need to know what the phase to phase value is as far as rubber gloves are concerned?
I guess to be insulated for enough just in case you connect them.
Correct, correct. What you'll have is a lot of linemen going out there in the world and thinking, well, my phase voltage is 7,200. So I need maybe the electrical double on insulation. So all I need right here is a 15 kV glove. Well, guess what, gentlemen? If you go up and you start working on this pole and you've got a 15 kV glove and you're working between phases, there is the potential for how much voltage?
300%. Well, it'd be 200%.
It'd be the 12,470.
No, it'd be 173.25%. Remember, there you go. So actually now I only have enough insulation if I'm wearing a 15 kV glove, because I'm thinking phase to ground. And actually I'm working in the vicinity of 12,470. My glove's underrated. So that's why you guys need to know and be able to compute what a phase-to-phase voltage is. There's other reasons for it, but that's the safety reason behind it. We talked about rubber gloves in the video that Robbie had this morning. Santee Cooper. How many pairs of gloves did you have, Robbie?
I had 2 pair.
How many? 2 pair?
I did, yes.
Yeah. Everybody pretty much carries on the system 2 pairs of gloves. The distribution rubber glove was rated to 20 kV. Almost double of the 12,470, but plenty of room there. You had 7,530 volts worth of insulation, plus you had a lot of room going on right there. On 34 kV, which is 19.9 phase to ground, they were a 40 kV glove. So you had 2 sets of gloves you had to ride around with all the time. Can I take a 20 kV rubber glove and work on a 34 kV line?
Negative.
Negative.
No.
Negative. That's super dangerous, gentlemen. But I can take a 40 kV glove that gives me 4,500 volts of extra insulation, and I'm good to go in that situation. There is no other rubber glove made above 40 kV. 40 kV is as high as they go on a rubber glove, and we'll talk. 34.5 kV is the top of the distribution voltages, and we'll talk how transmission does work later on.
What was the size that you had, Professor V, in the field?
I had a pair of 20 kVs.
No, the one that Professor V had in the field that we tried on.
Oh, what were those?
We didn't, in our system, we didn't work on 34, so we just had a 20 kV.
What size did you have out there in the field the other day? Those are
25.
25s?
Yeah.
There you go.
25.
25.
And so those 40s got to be thick, huh?
Yeah, those 40s are like wearing a tie around your fingers, and your hands will get tired. Kind of off track and off beaten path right here. When you're working in those types of rubber gloves, see those fingernails? Keep your fingernails short, as short as possible. Don't bite them off, but keep your fingernails short, because if you start working in rubber gloves like that all day long, the rubber on the inside of the glove will push your nail up, then sweat and garbage and trash and glove powder and everything will get up under the nail, and your nail will get infected. So keep your nails short with working with rubber gloves. I think that pretty much, for now, summarizes how we're able to get voltages, what 3-phase is on the primary side, and how we're able to determine what the voltage is. Now, I can guarantee you this, guys. You give it about 30 days of working on a system with a Robbie Vermeulen or a Scott Shoemaker on a line crew, you guys are just going to know inherently, yeah, that's 7,200.
Right.
I've got 2 phases on that pole, that's 12,470. It's just going to come like clockwork. It's going to be in your memory banks all the time. When I get ready to go to work on a 12,470 pole, I need my 20 kV glove. So the company is going to provide your gloves. And if you got dual voltages like that, they're going to provide you 2 sets. You're going to have 2 sets with you. 2 sets are going to be off tested. So they're in rotation. So actually you have 4 sets of gloves, rubber gloves. All right, any other questions there? Robbie, anything you'd like to add?
I'm just gonna piggyback on what we talked about with the rubber glove safety, guys. That is your lifeline. That will be your lifeline, and you just keep them stored in a good, cool, dry place, or it doesn't have to be cool, but a good dry place away from chemicals and those kind of things in a glove bag. And you guys can look at mine when we get to the yard today. I've got them in the back of the truck. Put them on. If you want to climb with them, see what it's like. But I mean, that is your protection.
Mm-hmm. That is, you can't stress it more, can you?
No, I mean,
yeah, those are your babies. Those,
yeah.
If there's anything that you want to take care of,
yep,
and keep close to you, and keep on all the time, it's your rubber gloves and rubber sleeves.
Yep.
you brought something up there that I've seen some common problems, and I still see it today when I look at the back of the trucks driving around. Don't leave your rubber gloves sitting right around the back of the truck. The UV damage just will damage them. It'll damage the cup, and you'll get ultraviolet damage from the sun. Here's a great one I saw a lineman do before. He took his rubber gloves and threw it in the bin with the chainsaws.
Oh.
What's the problem there?
It's sharp.
Well, sharp is one thing. The worst part of it was rubber and oil and gas don't mix.
Yeah.
Right? You put them in gasoline, and the other one was the employee, and you're going to be using conduit glue, threw it in a bin with a bunch of conduit glue that was spilled all over the place. Keep them away from chemicals. All right. We've been talking almost for an hour here. Let's take about a 10-minute break. Smoke them if you got them, and we'll come back.